Hello, my name is Hyugo and Rufino. Today I'm going to teach you about the Newton's second law of motions. The acceleration of an object caused by a force is directly proportional to the magnitude of the force and inversely proportional to its mass by Sir Isaac Newton. I'm going to describe you from the basic, the formula, and a problem that we will need to solve. I'm going to introduce you to the Newton's second law of motion. The Newton's second law of motion will occur when an object is in motion, but to be noted that the Newton's second law of motion doesn't have a constant velocity and the resultant force is not equal to zero, so there will be accelerations. Now, the acceleration will be affected by two factors. Now, I'm going to explain to you about the acceleration that we will be using in the Newton's second law of motion. Now, acceleration is affected by two factors, which are force and mass. Force. Now, let's say we have two boxes, box A and box B. Both boxes have the same amount of mass, but are being pushed with a different amount of force. Box A is being pushed with 90 newtons and box B is being pushed with 60 newtons. Now, box A will obtain and acquire the greater acceleration than box B, because the greater the force, the greater the acceleration, and the smaller the force, the smaller the acceleration. Now, we're going to go to mass. Mass is actually the opposite of the force. Let's say we have two boxes again, box A and box B. They both have different mass, but they are being pushed by the same amount of force. Box A has 10 kilograms of mass and box B has 20 kilograms of mass. Now, box A will acquire or obtain the greater acceleration than box B, because the greater the mass, the smaller the acceleration, and the smaller the mass, the greater the acceleration. With all that being said, now we're going to construct the formula by using acceleration, force, and mass. As I said before, there will be force, mass, and acceleration. There is resultant force or force resultant that is a unit of Newton, mass that is a unit of kilogram, and acceleration that has a unit of meter per second squared. There are two formulas from the second Newton's law of motion, but both of them are the same. So you can use the first one or you can use the second one. But for solving the problem in this video, I'm going to use the first one because it is much simpler to calculate with it and it's much simpler for me to memorize it. Now, let's head on to the problem that we will be solving. Questions and discussion are the problem that we will be solving in this video. Let's say a box is being pulled by three forces that has direction as shown below here, and because there is a force pulling from both of the opposite directions, two from the left and one from the right, the box moves with the acceleration of 0.5 meter per second squared. Now, what is the mass of the box? First, we need to write what we know from this question. The force from the left is 10 newtons and 6 newtons. Add them together and we will get 16 newtons. The force from the right, which is 8 newton, and then the accelerations, which is 0.5 meter per second squared. Now we're going to write what is being asked in this question, which is the mass of the box. Now we're going to write the solution and the way to solve this problem. The force resultant is the amount of the force acting upon an object. In this case, there will be 3, but we already add 2 from the left into 1, which is 60 newton. We're going to subtract it because each of the forces are facing the opposite direction. So 60 newtons minus 8 newtons equals 8 newtons. Now, resultant force equals mass times acceleration. We're going to input the formula. Resultant force 8 newtons, mass is being asked, and acceleration is 0.5 meter per second squared. Now we're going to obtain the mass equals 8 newtons divided by 0.5 meter per second squared. We're going to obtain 16 kilograms. So the mass of the box is 16 kilograms. Okay, I think that's all my presentation today, and that's all what I can teach you today about the Newton's second law of motion. Thank you for your time to watch this video and have a good day.